Hello, everybody. Happy Monday, Monday morning, Monday afternoon, Monday evening, whenever you're getting this. Hopefully, you had a good weekend. Move that out of the way. Hopefully, you had a great weekend. We're eventually going to move into graphing quadratic inequalities this week. But before we do so, I want to mention or comment, reply to some questions that I had on Friday about the quizzes. The quizzes we give you, Mr. Klug and I, some of you have concerns that they're not asking the same work or the same type of problems as we do on our homework. And in some cases, that's very true. In the quizzes, we're asking for more why the concepts behind it, not just how to do the skill. If you're listening to these videos that Mr. Klug and I are giving you, hopefully you're getting out of it not just how to do it, but why and the understanding behind it. So in the future, if I have a recommendation, it's that when you're listening to these videos, please listen to the whys behind, not just the how to do the skill. So eventually we're going to get into graphing quadratics today. But before we do that, I want to just review a little bit here on where we've been and where we're going. The review of one variable inequalities, these right here. Remember, we solved them and they only had one variable. Obviously, we graphed them on a number line. And in that case, now again, going back to that question about the quiz answers and types of problems, in this case, any number that's in this dark shaded purple region, in this case, it's number line, will make the original inequality true. So we can pick the value of 4, we can pick the value of 10, we can pick the value of 400, we can pick the value of 4,553. Any point that's to the right or greater than -3 will make that inequality true. On the other hand, any point over here will not. Any value will not make it work. When we move into two variable inequalities, like this one right here, again, it's a two variable inequality, x is endwise. Now we're on a coordinate system. It's a two-dimensional, it's no longer number line. But again, the shaded region gives the solution to the inequality. Any point in this shaded region over here, whether you draw arrows or whether you color it in or however you choose, any point that's over here makes this inequality true. So if I pick the point 0, 0, it's in the shaded region. If I put it into this inequality, I'm going to get 0 is less than 4, which is a true statement. If I pick the point -5, 5, if I put -5, 5 into this inequality, it will make it true because it's in the shaded region. We're coloring in those ordered pairs that make it work. These over here do not make it work. They are in the unshaded region. So today, now we're going to get into solving and graphing another type of two variable inequality, very similar to these, more like these because it's two variable, but in this case, they're quadratic. Quadratic meaning, hopefully, power of 2, graph a parabola. So all of the steps are going to be exactly the same. Write the corresponding equation, graph the equation to find the boundary. There's the keyword boundary. In this case, the boundary is going to be a parabola, not a line. Determine if that boundary is part of the solution, solid or dashed. Test a point in the region, and then shade those that work. The steps are exactly the same, exactly the same. I'm just going to turn my iPad for a second. Gives you a bigger screen to see. So again, the steps for following or solving the inequalities are exactly the same as they were before. So here's an example of one that we can do. We want to graph the inequality. It has, as we said before, a power of 2, making it a parabola, quadratic inequality. The first step we do is write the associated equation. Literally replace the inequality with an equal sign. And now we want to graph that. We want to graph the equation, which is our boundary. Whoops. We're graphing the boundary. To do so, we have a lot of steps because now it's a parabola. It's more complicated than a line. So if you remember before we left school, before we left the actual building, we were graphing parabolas. and we found their x-intercepts, and we talked about the vertex and the axis of symmetry and all that kind of thing. We're going to put that all to use right now. So hopefully this is a little bit of review for you. I'm going to switch to purple. To find the x-intercepts, remember we let y equal 0 and solve for x. We substitute y for 0 for y, and then we solve for x. So x squared plus 2x plus negative 3, take out the y, put in the 0. And now we solve it. To solve it, remember many of you are still going to go back to your diamond and rectangle. That's perfectly okay. Use your diamond and your rectangle to factor. I'm not going to go through the steps of diamond and rectangle because I'm hoping we know how to do that by now. Otherwise this video is going to get really long. But again, using your diamond and your rectangle, you come up with your factors. Set each factor equal to 0. The zero product property. So we find that x equals negative 3 and x equals positive 1. So we then have x-intercepts. Remember, that's what we're trying to find. We have x-intercepts of negative 3, 0 and 1, 0. So I'm going to slide down. We're kind of cheating here. This is the inequality we're trying to solve. We have x-intercepts of negative 3 and positive 1. So graph those x-intercepts. They're going to help us. Now, if you remember from before we left school, the vertex of that parabola is going to fall on the line of symmetry. The line of symmetry is what goes right down, smack down the middle between those two x-intercepts. Oops, helps if I graph in the right spot, right? That's supposed to be negative 3. Negative 3. Sorry, put that in the wrong spot. Negative 3. So when we're looking for our axis of symmetry, it's going to right down the middle. If you can find that without doing any work whatsoever, fabulous. Sketch it in there. Right down the middle between the two x-intercepts. In this case, that's going to occur at x equals negative 1. Now remember, that's a vertical line. It's all the ordered pairs that have an x value of negative 1. It's a vertical line. Now, what if we couldn't find that simple? What if it wasn't that easy? Then, if you remember, the axis of symmetry actually is an average between those two x-intercepts. It's right down the middle. So we could actually find the average formula from way back when you were in, I don't know, 5th, 6th grade, whenever you learned that. To find the average, we're going to add two things together and divide by 2. Add whatever you're averaging, add them all up, divide by how many of them you have. So that's negative 2 divided by 2, so that's negative 1. And again, that's where our axis of symmetry equation comes from. That's the equation of the line, the axis of symmetry. Now, why do we find that axis of symmetry again? Because our vertex has to fall right on that line of symmetry. Our vertex goes right down the middle. Now, it might be up here, making the parabola open down, or it could be down here somewhere, making that parabola open up. We don't know. We need to find the y coordinate that goes with that x coordinate of x equals negative 1. So to find that vertex, in this case, we're going to let x, oops, I don't want that color. We're using pink. We're going to let x equal negative 1 from right here. Let x equal negative 1 and find the y that goes with it. That's going to help us find that point. Where on that line does our vertex fall? So again, my equation, now remember we're going back to the equation we're trying to solve, or excuse me, trying to graph. We're trying to graph this equation, which is a parabola. So coming back down here, I'm going to put negative 1 in for the x. And I'm going to find y. So 1 plus negative 2 plus negative 3 equals y. That y is too big. So negative 1 plus 3 would be negative 4 equals y. I now know that my vertex is at Remember the x was -1, and now my y is -4. So now I can go back to purple, and I can graph -1, -4. There's my vertex. These are my x-intercepts. And now I can sketch. Now remember, this is a sketch. It's not an exact science. This is a sketch of a parabola. It's going to look something like that. Now, they don't necessarily go straight up. It kind of looks like it's straight up and down. It's not necessarily supposed to be. Maybe I should change that up a little bit. That looks too straight, actually. It looks something. I don't know if that's any better. But anyway, there's my parabola. Now again, if we go back to the directions, same directions as before, technically all we've done so far is graph that equation. We're only on step 2. So we graphed the equation. Now we have to determine, is it solid or is it dashed? Is it part of the solution or is it not? Remember, this is the inequality we're trying to solve. Is it part of the solution? Is it part of the solution? You betcha it is. The boundary works because of this equal sign right here. So we're going to make it a solid boundary. Which way did it go? Greater than or equal to. Because of the greater than or equal sign, our boundary is solid. So I'm going to leave it that way. Now, just like every other time, now we have to decide which region are we going to shade. Same idea as on either side of the number line. Is it on the coordinate system? Is it on this side or that side of our boundary line? In this case, we have to test points. So I'm going to coincidentally pick 0, 0. Is 0, 0 a solution? Now remember, we're going back to this inequality. That's what we're testing. So true or false? We're going to get -3 is greater than or equal to 0, which is, whoops, that is not true. That is false. So if I come back over to my graph, this is false. Does not work. I am not going to color inside the parabola. I'm not going to. So more than likely, I'm going to be coloring outside here. Not a bad idea to test it though. So let's test a point outside. I'm going to test the point right here. I'm going to test 5, 0. You can pick any point you want that's outside the parabola, not on the parabola. So if I test 5, 0, 5 squared plus 2 times 5 plus -3 greater than or equal to 0. 25 plus 10 plus -3 greater than or equal to 0 would be 35. 32 greater than or equal to 0? True. So this one works. So because that point out there works, I am now going to shade. And whether you use arrows or lines or, again, you could, whoops, that's not the color I want. You could shade simply by doing this. Or if you don't like that, you can use your highlighter, your fancy highlighter. And we're going to shade all the ordered pairs that are outside that parabola. And you can be really creative with a cool highlighter if you want to. Again, just because I'm staying in the coordinate system doesn't mean those are the only ordered pairs. Anything outside that parabola, any random point outside the parabola will make this true. Clean that up a little bit just to make it look neat. It is any point. So back to the quizzes. When the quizzes say, is the point right here, is positive 5, negative 5 a solution? Yes, because it's part of the shaded region. Is the point positive 1, 8? Is positive 1, 8 a solution? No, because it's not shaded. It is not in the shaded region. None of these work. All of the ordered pairs out here work. So that's a lot of work. It's a lot of work for one problem. We're only going to be a couple of them. Take your time. Again, when you're watching these videos, please listen to why things happen, not just how to get it done. Again, contact any of us if you need some help. Meeting us with us virtually will make it a lot easier than trying to answer questions on email, folks. Please, please, please meet with us during office hours or get a hold of us and we can set something up. But meeting virtually makes it a lot easier because we can show you how to do it like on an iPad. We can work you through it and make it work. So hopefully it works. Otherwise, find us. Have a great Monday.